the last part of mechanical vibration, okay? And we could zoom by so quickly is because of this extra 2 hours that we have, okay? When I was teaching this in 2017, I took 4 weeks to complete where I am now. Now we are only in second week, okay? But before I go on, how do you feel about mechanical vibration? Is it that bad? It's not that bad, okay? I hope you okay, tell me why is it very bad? Can you don't be shy, okay? What stays here remains here and is recorded. Okay, I'll do that. No imperial units. Okay, yeah, I also like when it's imperial units, I go like, whoop. Okay, okay. So it's not so bad, right? Again, I hope by the end of next week, I can show, or I can what is the word? Show you the formula sheet. Okay, it's not that bad yet. I'll show you what is really bad if you have a few minutes. If I can show you something really bad, okay? Uh, I wonder, do I have it? If I have it, I will show you. Okay, okay. Final exam. Does this look familiar? Yes or no? Then we have to do this. Oh shit! And then we have to do this. Holy crap! And then we have to do this. Whoa! And then we have to do this. Listen. This was held in 2017. It's recorded. Don't worry, you will get the question. 2017, the exam was 3 hours and I make the student do 5 questions. Okay? Okay, I make them do 5 questions. But for you, 2.5 hours, I only make you do 3. Okay? Okay? So, yeah, but if you see questions like this, it's not difficult at all. Trust me, it's not difficult at all. Okay, it's really, really straightforward. Don't panic, okay? As I say, you panic when I panic, okay? I don't panic, you don't panic. Right. Okay. If I show you the marking scheme, I think all of you will drop the course and take it again later. But no. Right. So the next thing, the last thing that we're going to do, okay, is we are going to look at the performance measure. Okay, the performance measure for under dam. Okay, for under dam mechanical system. I repeat again, we are going to look at performance measure for under dam. So if I were to draw this system out, the system that we have will look like this. So there will be a spring and damper system, and there's a mass. Okay, there's a K and there's a C. I want to make sure that I've started recording. I did. Okay. So in a system like now, what I'm teaching down here can be used in mechanical vibration and control theory. How many of you are doing your control course now? Next semester, right? So what I'm teaching you down here, the mathematical description can be used in both mechanical system and what? And your control theory. Because fundamentally, they are both the same thing. Okay. So now, if we have a spring mass damper system, our general solution will tend to look like this, right? X as a function of time, this will be equal to E minus alpha t, C1 cos omega t, plus by C2 sine omega t, and then plus by XSS, okay, where XSS is known as steady state. Now, most of the time, this is the first time you see XSS over there. By right, there's a XSS, but most of the time in mechanical vibration, XSS is equal to what? 0. That's why it has been what? It has been dropped. Okay. So before I go any further, I want to elaborate on, I'm going to introduce you to a new term. Okay. I'm going to introduce you to, so for a damped mechanical system, right? We are aware that the roots are equal to minus alpha plus and minus beta, right? So remember, we recall what is alpha and what is beta, right? So this will be equal to minus C over 2m plus and minus, and we are aware that this is square root C squared minus 4mk divided by 2m. Okay. So I'm going to rearrange this expression over here, especially the term on the right hand or on the extreme right. On the left hand side, we cannot do anything, it's still the same. I'm going to now put this, okay, and introduce the 2m into the square root. So this is C squared over 4m squared minus by 4mk over 4m squared. Okay. So we can do a bit of readjustment. So minus C over 2m plus or minus, and we will know that this will become C squared over 4m squared, right? And then we know we can cancel the 4 and 4, the m and m. We know that this is k over m. Okay. So what I'm going to do now is we are going to take out k over m. Okay. So this will be equal to minus c over 2m plus or minus. I'm going to take out square root of k over m. And then we're going to multiply now. Okay. So this is equal to c squared over 4mk, right, minus 1. Okay. You'll get me, right? So because I factor out K over M, I need to introduce this K at the denominator. Okay. So the next thing we're going to do is we're going to let omega n, which is equal to square root K over M. And omega n, as we already know, is the undamped natural frequency. Okay. And then I'm going to introduce you to a symbol. And this symbol over here is known as zeta. I don't think I drew it rightly, but it's zeta. So zeta squared is equal to c squared over 4mk. Okay, I'm going to call it zeta. And zeta is known as your damping factor. Okay. Is known as your damping factor. So if we look at minus alpha plus and minus beta, this can be equal to minus c over 2m, right?